You're listening to The Skeptic's Guide to the Universe, your escape to reality.
Hello and welcome to The Skeptic's Guide to the Universe. Today is Wednesday, August 9th, 2017, and this is your host, Stephen Novella. Joining me this week are Bob Novella.
Hey, everybody.
Kara Santamaria.
Howdy.
Jay Novella.
Hey, guys.
And Evan Bernstein.
Good evening, folks.
So, guys, once again, we're under the gun here because the world is going to come to an end in like less than 2 months. Again.
Oh, I hope it's zombies this time.
Yeah, right, Bob? Finally, come on. What's happening this time, Steve?
September 23rd. Right. This time it's really going to happen. Have you guys heard of Revelation 12?
It's a fragrance by Calvin Klein.
Yeah. Again, it's like people reading Revelation and finding connections and thinking that that's what are the odds that there's total like pattern recognition. So they take this part of Revelation where it talks about the woman is standing shrouded in the sun with the moon at her feet and with the 12 things in her crown, and they're saying, okay, so the woman is clearly this constellation, and there are 9 stars in Leo. But then we're going to add in 3 of the planets, and that makes 12. That's the kind of shit they're pulling, right?
I'm so confused already.
Yeah, right. And then the moon, and then the sun will be going through the constellation. That's why it's shrouded in the sun. So they basically found this way of retrofitting, some astrological nonsense, and forcing a fit to it. And they're convinced that this means for reals that the world is going to end, the rapture is going to happen, and there you go.
So that's happening September 23rd.
Yeah.
And the other thing I want to say is that was there a Revelation 13? Because there shouldn't be if 12 is the one where the earth ends, right?
Yeah.
Right. What's the point?
I think that's just a reference to the paragraph number,
So there are people that are prepping for this religious totality end of the world event to take place.
No way.
Yes.
All
there
right.
are people
Preparing.
that are hunkering down, that are trying to make themselves, be in remote, safer locations when this, whatever really they think is going to manifest is going to take place. But this is what I don't get. People who are religious that prepare for the rapture. Why? What are you preparing for?
Yeah, ours just going to be whisked away.
To ascend.
Yeah,
but they want to have enough quest bars for the journey.
I just don't understand. It doesn't make sense.
You're right,
to
Jay.
me.
What preparation? Why would you need to make any sort of preparation? What's the difference between
I could see if you want to lose some weight so that when you're lifted in the air, it's a little bit easier. But other than that...
Wait, isn't the Revelation thing, and maybe I'm wrong here, but isn't there supposed to be like a big war? Like they're going to have to be in a bunker for a while where like all the bad people...
Yeah, that's the Pockeyclips, yeah.
Oh, you have to survive Armageddon?
Yeah, you have to survive that, and then you go up on a white horse. I think.
Is that it?
What it is?
No. What they think is that when the first thing that happens is all the good people get raptured, they vanish.
Oh.
Then there's hell on earth, and it sucks for everybody else.
Well, then, what's the point of the bunker?
Yeah.
Oh, maybe it's...
If you think you're going to be one of the people left behind, then,
your faith is not that strong, I guess.
Not much you can prepare for there.
It is a contradiction. I'll give you a point
but
there,
aren't
Jay.
there are there going to be like locusts and crap that are trying to eat your
hell
face?
yeah. You kidding me?
Oh.
But that's after you've already gone up to the holy places.
Yeah, right.
Crap. I don't know then.
Right.
Can't explain it.
Well, I wish you all good luck.
Yeah.
First,
Yeah.
maybe buy a couple extra bottles of water or something to be prepared.
Well, okay, guys.
Duct tape and toilet paper.
We have weathered quite a few ends of the world. I think we'll survive one more, but we'll see.
Can only hope so.
Ready for the one after that. Right.
Yeah, you never know. All right, Kara, we're going to start with what's the word?
Yeah, so the word this week was recommended by Jeffrey Youngs from East Lyme, Connecticut. He said on episode 612, Kara used the word, and I'm going to preface this because I always pronounce this word wrong. I probably said gestalt, as if it were a commonly understood word. However, I had no idea about it except that it was the version of the Nier video game with the good muscle daddy. Does anyone know what that means?
Nope.
No.
Muscle daddy?
Well, Jeffrey Youngs does.
That,
This seems like a word that could have some interesting meat to it besides the standard dictionary definition. Please consider it. So yes, I shall. And of course, I got another write-in from a different listener who heard me say the word both on SGU and on my podcast, Talk Nerdy. And he's from France, and he yelled at me for pronouncing it wrong. You didn't really yell
Gestalt.
at me.
Gestalt.
Yes, it's Gestalt. It's German. It's Gestalt. I don't know. Literally every psych professor I have ever had living in the South said Gestalt. It must be a regional
my God,
thing.
that's horrible.
Yeah.
That's
Never,
a regional,
ever
it's a
heard
regional
that.
thing.
Yeah.
And I
but-
didn't notice when you said it. Otherwise, I would have mocked you earlier.
Yeah, but it is Gestalt. Hard G,
Gestalt.
S-H-E sound.
Yeah.
Gestalt.
Jawohl,
And the
Gestalt, mein
Gestalt.
Führer.
Very, very German.
Wolfie.
And so let's talk a little bit about what it means.
Let's get the whole idea first. Just give us the whole sort of overview.
The whole Gestalt of it
The big picture.
is this idea of the sum is greater than the whole of its parts. This is kind of the general definition. If you look at dictionary definitions in Merriam, it says something that's made of many parts and yet is somehow more than or different from the combination. If Oxford says something quite similar, an organized whole that is perceived as more than the sum of its parts. Gestalt, though, can also be used as a more broad definition. I think it has sort of evolved into a description of just the general quality or character of something. So Merriam's example is, quote, when new employees are recruited fresh out of college and can look forward to working for the same company for 40 years, it changes the gestalt of management. So this might be a more literary way. It's like the kind of holistic view of something. But Gestalt really translates directly from the German into this idea of the organized whole having a different quality, a greater quality, some sort of quality that is distinct from a reductionist view of the individual parts of it. And Gestalt psychology is an entire field of psychology that sort of came out as a response to the William James or the Wundt form psychology, which was heavily like an a molecularist. Yeah, there you go. An atomist, a molecularist, a reductionist view. There was a very strong push in psychology towards the scientific method, which was a good thing. And some psychologists worried that experimental psychologists took it too far and everything was a point-to-point correlation. So they would look at things like human behavior and emotion, and they would say, if we can't reduce it to individual parts, it has no meaning and we therefore shouldn't study it. And so Gestalt psychology came out of that. It was really the work of Max Wertheimer and others. And Gestalt psychology, in a lot of ways, kind of fathered what we now know as modern perception. There are these Gestalt laws that came out of it, all these different laws you've probably heard of, the law of closure, the law of proximity, the law of apparent motion, of similarity, where they started to study why it is that we see things that are novel against an unnovel background, or why when we see apparent motion is a good example, like a Christmas light that blinks, one then the other, then the other, then the other. It's really, stationary lights that are blinking in succession, but it looks like there's a light spiraling up the tree. And so they really started to dig around that. And ultimately that led into some interesting perceptual studies in neuroscience and a better understanding of how visual perception actually works in animals and human beings. So super interesting, good history. It's a word you hear a lot in psychology. I have a long background in psychology. I'm actually going back to school now for my PhD. I know I'll be hearing it quite a lot again as I embark on that. So let's talk a little bit about the etymology. It's pretty straightforward. It's actually a German word, but the cool thing is even the German word evolved over time. Early on, the word Gestalt in German was the past participle of the word stellen, which actually meant to set, to place, or arrange. So it looks like what happened is that Ungestalt, which is like the opposite of that, was actually a word that was used to talk about things that were wrong, like misshapen or deformed. Like that Ungestalt was something that was deformed, even though the word Gestalt no longer was used in popular language and had kind of lost its meaning. And so the new version of Gestalt actually sort of came out of Ungestalt to mean shape, form, figure, configuration, appearance, all of these different things. They say it doesn't perfectly translate, which is why we still use the word Gestalt, because it's not exactly the shape or the form or something, but it's how things come together to create their form or shape. And so that is the Gestalt of it all.
Cool. I love that word.
I love it too.
I do like that word.
Kara,
it's a
there
good
is
word.
in medicine, we talk about Gestalt diagnosis or a clinical Gestalt. And that is essentially refers to making a diagnosis by getting the whole picture. And it is a pattern recognition, intuitive type of diagnosis that's based upon experience. So like when you've seen something so many times that you see it again and you're like, you just, the overall impression, you make the Gestalt diagnosis, or you just understand the situation because there's just all those little pieces add up to something you're familiar with.
Because there's so many symptoms.
Yeah.
Like you look at somebody who's diabetic, who's been undiagnosed for a long time. It's not just going to be their blood sugar. You're going to see that they've got maybe some nerve damage, their vision's going, and you start to see all these hints and you're like, oh, that's probably diabetes before you even do the blood test.
Yeah, right. But you still have to do the blood test, right? So,
absolutely.
And there's a lot of debate that goes on, among those people who like to think about such things as to what the optimal relationship is between this sort of pattern recognition Gestalt approach to diagnosis and management and the more analytical detail
sort of bottom-up,
fact-driven bottom-up approach. Yeah, so it's like the top-down versus bottom-up approach, and that's with many things. The consensus is kind of in the middle, that you want to get the best of both worlds, right? You want to get sort of a head start with your top-down pattern recognition Gestalt diagnosis, but then you have to back it up with the analytical details to confirm your suspicion and make sure you're doing the right thing. So
you're doing the right thing. Yeah, you're not misdiagnosing. I think another really good example of that would be if anybody has read the book by Oliver Sacks or seen the movie Awakenings.
Oh, yeah.
Kind of, it goes through his process of figuring out what this post-encephalitic fever was that was misdiagnosed in all these people, because nobody had really defined it before. But when he started to see these core features that they all were embodied, even though they had all these different diagnoses and different small things could be pulled out, he saw, oh, there's a pattern here, and eventually was able to diagnose that.
Yeah, that's a great movie, by the way, if you've never seen it.
Absolutely.
I often reference that movie, and now I'm getting to the point where medical students haven't seen it, and they look at me like I'm an old guy.
Good.
When I know, but it's like my references are getting old.
That's Robin Williams and Robert De Niro, honestly, at some of their finest, it's so well done.
It's a
but
great
movie. You need a box of Kleenex when you watch that movie.
Yeah, that's a hard one.
Be ready for that.
Yeah. All right. Well, before we go on with the news items, I just want to mention that we have a great interview coming up later in the show with Jeff Hall, who is the director of the Lowell Observatory. We're going to geek out about some astronomy, especially with the upcoming eclipse and all.
Squee!
But let's get on to some news items. Jay, you're going to tell us about how our brains are wired for taste.
Yeah, they are. As a matter of fact, I just found this out, that our ability to taste isn't just because we love to eat meatballs and watermelon.
Yeah.
At least for me.
It does go beyond that, yeah.
So we can sense bitter, sweet, salty, sour, and savory, or also known as umami. Umami. That always reminded me of Star Wars Episode 4 when the Jawas say Utini. Utini.
Yeah.
You guys are such nerds. I love you.
So we evolved.
I bought Jay a T-shirt that shows
it's a Jawa, and it has
Jawa, and on the bottom of the shirt it says "Utini," because Jay and I have been laughing about that for decades. That one little sound for decades. I saw the shirt, like, I'm getting that for Jay.
And of course, actually, he's saying zucchini.
Yeah.
There's people that I've heard a lot of funny things that people hear, like they can hear words in what the Jawas are saying because they're speaking nonsense. But I always thought that when that Jawa whispers to the other one in the cave when they're looking at R2-D2, that he says,
"The bow man."
He says, "Pass the bowl, man." Pass the bowl, man.
Oh, no way.
Yeah, so next time you watch the movie,
a little audio pareidolia.
Yeah, definitely. All right, so anyway,
I saw a Jawa costume at Dragon Con a couple years ago that was spot on with the sound.
I got the picture of that.
And
it was
everything.
Great.
It was fantastic.
The eyes lit up. It was beautiful.
That was
beautiful.
So we evolved to be attracted to sweet foods.
Of course.
And jealous.
And we're supposed to also be turned off by bitter or sour foods. And it
Which I am.
might seem obvious, but sweet foods tend to be more calorie or nutrient dense. And when we taste bitter, this is our body's way of warning us, the user, in a sense, that something might be poisonous.
Comes in handy.
It is very handy. I mean, we absolutely evolved to have these traits, and our ability to taste bitterness exists. This ability exists in many species because of how life-saving it actually can be. And there's a study where they found that the TAS2R bitter taste receptor gene in 54 vertebrate species, including mammals, birds, reptiles, amphibians, and fishes. So we have that in common with them. Animals that have more effective taste buds, they can detect toxins better and are less likely to ingest something that can kill them. So there's a huge evolutionary benefit to tasting the environment. How does this work? I'm going to talk a little bit about how taste works, but there's an actual news item wrapped up in this and some recent study that went on that found some very interesting things about the way we taste. So the cells on our tongue that can detect the different tastes are called taste receptor cells, and they're continuously dying off and being replaced. So before I read the answer when I was researching this, I asked myself the question I'm about to ask you guys. How long do you think that the taste receptor cells that are on our taste buds on our tongue, how long do they live for?
4'1".
Okay.
13 days. 13
if
days.
they don't regenerate, they last a long time.
Yeah, I do think
They
it's
do
probably
regenerate,
I would
then
say
it's
21 days.
21 days? Okay, but I think that probably certain things like capsaicin can probably make turnover go faster. That's my guess.
But I didn't ask
3
you that
days.
question.
3 days.
right.
I'll say
This
3.
is the journal. Like this is. I shouldn't say journalist because it's not the. This is the person who goes on TV. You start to develop the skill of answering the question you want to answer instead of the question you were asked.
There's a nice sidestep, but Bob,
Yep.
wow. Ding, ding, Bob, you won. It's 2 weeks.
Yeah, I've read the damn article. Come on.
Okay. So
Good thing that wasn't science or fiction.
the truth is that stem cells are constantly producing these taste receptor cells to ensure that we can continuously taste things. And this is an important thing to consider here. And this is the root of the study. Scientists were curious how these cells stay wired to the brain when new ones emerge so often. Now let that sink in for a second. These new cells, the cells are dying and are replaced every 2 weeks, and yet they have to be electrically mapped to your brain in order for your brain to sense what the cells are detecting, right? You get that?
Right, so sweet has to map to sweet in your brain. If it's sweet is mapped to bitter and vice versa, then you're kind of screwed.
Yeah,
Ooh.
but that's. I guess is it a smaller connector at your tongue?
No, it's actually, there's a mechanism here that they discovered that's fascinating.
Oh, okay. All right.
So keep in mind the fact that we have continuous taste. We can reliably always taste, even though that these cells are dying and regrowing all the time. And there's no interruption between the new cells and their communication to the brain. The new cells have to be wired correctly to the neurons, and they have to be wired correctly each time. So every 2 weeks, those new cells appear, and they have to be rewired to existing neurons. Mm-hmm. So if mistakes were made, then our taste would be frequently shifting, which means we wouldn't be tasting the right things all the time or have consistent sense of taste.
But doesn't that happen as we age?
There is some definite taste die-off. I think it's very typical with old age that you'll lose some of your sense of taste. I don't know to what degree or if there's like an age bracket that this is typical in, but you definitely do hear people say that.
Yeah, and we become less picky as we get older too. Like we can handle bitter foods more bitter foods, and we don't want to eat things that are like super, super sweet anymore.
And so all of this stuff about the cells dying and regrowing and how do they remap and everything, it was unknown to researchers. So these researchers developed a test where they took genetically modified mice, not rice, genetically modified mice that had mixed up taste buds deliberately. They deliberately mixed up the way their taste buds are wired, so the researchers could see a bitter taste wired to a sweet receptor and a sweet receptor wired to a bitter neuron in the brain, right?
That would suck.
Yeah, and they did this using a single-cell functional imaging system. So each of these taste receptor cells can specifically taste or detect one of the 5 flavors: bitter, sweet, salty, sour, or savory. And when the specific cell detects the specific taste, it's designed for it to send a signal to the bundle of nerves that are found in the ganglion neurons that in mice is located behind the ear. And those are the neurons that send taste information to the brain. Okay? Now, the researchers then went on to trace how the ganglion neurons find and connect to the new taste receptor cells that they should be receiving signals from. And the researchers focused on bitter and sweet to make it simpler for them during this test. What they found was that two different molecules were in play. The bitter sensing taste receptor cells produced a molecule called samophorin 3A, while the sweet-tasting cells produced a molecule named samophorin 7A. And these molecules...
It's probably semaphorin. But...
Semaphorin, okay. Thank you, Steve. These molecules are already known to help neural circuits wire themselves correctly. So these molecules have known properties to already help the brain wire itself. So what the researchers observed that when those two molecules I just told you about were not created by the taste receptor cells, they could not wire themselves correctly to the ganglion neurons. They made the wrong connections. They just wired to random neurons. So more than half of the ganglion neurons were connected to the wrong taste cells without those two molecules being produced by the taste receptor cells. So when testing the mice, the researchers observed that the mice could not taste correctly, and they used plain water and water that was cut with quinine. It's a bitter chemical called quinine. I guess they were able to observe the behavior of the mice to tell if they were tasting something bitter or not. So those specific molecules that are made by the new taste receptor cells actually attract the right nerves to make a connection with them, ending with the taste system being wired correctly, which is a profound discovery because, it's another step in us understanding the way that the sense of taste is connected to the brain and, what's happening on the surface of the tongue, what's happening, between the tongue and the brain, how does that data getting to the brain? These are all like just incremental steps in our understanding of the way that our body is wired. The researchers believe that these results are also likely to apply in humans, just like they do in the mice, because we're very similar in lots of ways. And what I wanted to ask the researchers is, can they make my taste receptor cells only taste meatballs?
You would hate that.
No, if I could eat anything, I could just be like, all right, so today I just want everything to taste like awesome meatballs.
Yeah, but the thing is, it would be weird because you'd eat carrots and they would be like crunchy meatballs, and then you would stop liking meatballs because meatballs were the wrong texture because so
Not
much
true.
of flavor is texture.
Not true. Sounds good to me, Kara. Not every day.
Crunchy meatballs.
Also remember that taste is only, taste on its own is not that strong of a sense. Like, you need smell.
Yeah.
So even if it tastes like meatballs, if it smells like pears, it's going to be weird. The flavor is going to end up being weird in your brain.
Yeah, you're right. No, you're.
But what if you just
totally
got?
right.
What if you just got rid of the bitter taste and made all bitterness sweet?
Or just slightly less bitter. That's what I would like.
Yeah.
Like if all leafy greens tasted like butter lettuce.
What's that plant called? The berry?
Yeah.
The crazy berry?
But that just makes things taste wrong, right?
No. What it does is it causes your sour food, like sour foods, to actually taste sweet. So it does do something to the way that your brain receives.
That was an amazing effect.
Sensipalum dulcificum. Okay, so that's sweet. It's a plant known for its berry that when eaten causes sour foods, you were right, Jay, subsequently consumed to taste sweet.
Yeah, it has a molecule that...
Yeah, miraculin. Of course it's called miraculin. That's amazing.
Miraculous.
Yeah, and they sometimes call it the miraculous berry.
It binds to your tongue's taste buds. Interesting. I've tried
That's
it.
Cool.
It works. It also, it does skew flavor, not just to make it so you don't taste sour things, but it does skew the flavor of sweet things. But it was really fun. Like, you're eating a raw lemon and you're like, wow, this tastes pretty cool. It's interesting. It doesn't last that long.
But I got to say, it's not that surprising. I mean, of course, there's a signal that tells the nerves where to wire. I mean, that's how it works.
Oh, yeah. What are those called again? I'm trying to harken back to molecular biology. Are they tropic signals? Yeah, not trophic, but tropic. I feel like there's a difference.
Trophic makes them grow, and tropic makes them go to
tells
a
them where to
certain
go.
place. Yeah. Right.
Yeah, like the neurites, like the little growing
Neurotropin.
edges.
Yeah.
Neat.
All right, Bob, I understand that neutrino detectors are massive. Like, don't they have to build them like under the Antarctic, and they're huge?
Yes, but perhaps most likely not any longer, because researchers and physicists have confirmed a long-standing theory that neutrinos can be detected bouncing off of atoms. But not only that, this can be done using tiny detectors as big as a milk jug. Tiny. Now, this made me think of a scene from a Star Trek The Next Generation episode showing Geordi LaForge detecting a stream of neutrinos. Now, these neutrinos, we've talked about them many times. I'm going to describe them again. These are the most abundant matter particles in the universe. Trillions have passed through you since I've spoken these last 10 words. Bam. They don't interact with matter much, though, which is why you just don't even think about them or worry about them or need to even care about them, because nothing really ever happens. So that makes them, though, very hard to detect, which is why I kind of laughed a little bit when Geordi saw them using his tiny little his visors. Geordi's blind, and he has these special visors that let him see all sorts of wavelengths of radiation, including neutrinos. I was like, what? In that little tiny package? I mean, typically you need, when you hear about these neutrino telescopes or neutrino detectors, they're talking about isolated underground detectors, like a gargantuan swimming pool containing thousands and thousands of tons or more of fluid like water or something like that, to detect these neutrinos. And it's never these tiny devices. This is a big, big thing. So much water is needed because all the water has lots and lots of neutrons and protons, of course. And the more of them you have, the more likely it is for that very, very rare occurrence when a neutrino precisely hits one of the neutrons or protons, or the quark inside of it, and then which would then cause a reaction, releasing a muon, which is kind of a heavy cousin of the electron. And then this muon in turn releases Cherenkov radiation, blue light Cherenkov radiation, and then once that's detected, yes, we know we have spotted a neutrino. So yes, this is an incredibly rare event when it actually interacts with matter. A neutrino can go through light years of lead before interacting. So of course, so you need a lot of neutrinos and you need a lot of matter for it to interact with, to play those odds, just to get one or two little bursts of Cherenkov radiation. There is, however, this theory by Daniel Friedman, theoretical physicist emeritus at MIT. In 1974, he came up with his theory of coherent elastic neutrino nucleus scattering. I know that's a mouthful. So his theory is that since quantum particles behave like a wave, right? We've talked about that. Particles can behave like a wave at that scale. Low energy particles have bigger waves. High energy particles have smaller ones. These bigger waves with the low energy neutrinos would match the size of the entire nucleus itself, protons and neutrons, causing it to react to the whole nucleus and just bouncing off. So instead of interacting with a tiny piece of it, it's interacting with the entire thing. So here are the scenarios though. Up until now, we have a very rare event which is easy to detect. So that's the high energy particle with a tiny wave precisely hitting a quark, releasing the Cherenkov radiation. Now, though, we have something that's much more common. It happens much more often, but it's very, very hard to detect. And that's the lower energy particle with a bigger wave hitting an entire nucleus and causing this recoil. Now, Kate Schulberg, a physicist at Duke University, she had a great analogy. She said, it's like hitting a bowling ball with a ping pong ball. You can hit the bowling ball pretty easily, but it isn't going to roll very fast. Right? So this recoil of atomic nuclei caused by the low energy neutrinos has been looked at for years. They've been looking for this over and over, but our instrument sensitivity just hasn't been up to the task until now, of course. The new report in Science describes such a detection. So what the researchers did is they used a detector made of crystals of cesium iodide doped with sodium and all weighing only like 14.5 kilograms. Very, not heavy, not big at all. So when a nucleus recoils from a neutrino in such a crystal, even the tiniest recoil causes light to be emitted, which is easy to detect. So there you have it. That's how they pulled it off. They greatly increased the sensitivity by detecting the tiniest of recoils of these low energy neutrinos bouncing off the entire nucleus of these atoms. But you might be surprised to learn that this new technology does not make all big neutrino detectors obsolete. We're still going to need a lot of these big neutrino detectors because neutrinos come in 3 different flavors. It's through what's called neutrino mixing. These different flavors of neutrinos can morph into each other in various situations. So this technique that I've described, coherent elastic neutrino nucleus scattering, does not detect the specific types of neutrinos. It just detects the fact that some neutrino was there. But what we can do is, with this technology, hopefully in the future, is produce these really small and portable neutrino detectors that could have multiple uses, such as monitoring nuclear facilities for plutonium production. Yeah, that could be important. Or perhaps they can be used one day to create really cool glasses that can detect neutrinos.
And we can all be Geordie LaForge at that point.
Yeah.
That's neat. Yeah, it's like when I saw the picture, I'm like, really? That little thing is a neutrino detector? You know,
Right.
Really is shocking if you're used to seeing these massive underground detectors.
Yeah, like even I think episode of Cosmos, didn't it have Neil in a little boat in one of these these underground detectors, and they have to be incredibly isolated underground, really far, really deep, so that you're isolated from
cosmic rays and shit.
Cosmic rays, which can cause neutrino daughter particles to shower down, and other things that can create neutrinos. Like, for example, bananas. Did you know bananas emit neutrinos? Very. Not a lot, but it's like, that's bizarre just to think that they can emit them.
Do you know why? Like, why bananas and not, like, I don't know, pears?
I think there's little black holes being formed inside of the. Oh,
that's what those little seed things
That's what those black spots are on the skin.
Right.
No idea.
That'll appeal.
Because bananas are radioactive, that's why.
Yeah, but why?
Because of potassium. It's potassium decay.
Oh.
Yeah.
Potassium itself is radioactive, Steve?
Yeah, it just has a really long half-life.
Well,
but it's,
what other fruits or foods have a lot of potassium in them?
Bananas are my primary source.
Bananas the go-to.
Neutrinos? Primary source of neutrinos?
Yeah. Of neutrinos.
Gotta get my
and
daily
potassium.
dose of neutrinos.
So other foods that are high in potassium include squash, sweet potato, beans, yogurt.
Oh, does yogurt emit radiation? Is a Google autofill.
It does because it has a lot of potassium.
Yeah, that's amazing.
579 milligrams per cup. What if you have yogurt with banana? Then you're talking. All right.
Oh, then you...
Evan, so I understand that all atheists are immoral.
That's right.
Hey.
I didn't make it
That's
up.
what the science says, right? Yeah, so there was a study that came out this week titled Global Evidence of Extreme Intuitive Moral Prejudice Against Atheists, published in the journal Nature Human Behavior. And the lead author on this, Will M. Javeris. So they surveyed more than 3,000 people in 13 countries, ranging from secular strongholds like the Netherlands and Finland to very deeply religious places of the world, such as the United Arab Emirates and India. And in the study, the researchers told the participants a gruesome story in which a man used to torture animals when he was a boy. And then he grew up to kill 5 homeless people whose dismembered bodies are now buried in his basement.
Whoa.
Half of the respondents were asked this. Which is more probable? 1, the man is a teacher. Or 2, the man is a teacher and does not believe in any gods. The other half of the participants were asked, which is more probable? 1, the man is a teacher. Or 2, the man is a teacher and a religious believer. About 60% of the people who had the option to flag the teacher as an atheist did so. And just 30% of those who had the option to flag the teacher as a religious believer did so.
Well, this is a bullshit study.
It's, I don't really buy
I'm
it.
having some real issues with the design of this survey.
First of all, the correct answer is 1 in both of those. Because
but that also is testing somebody's, like really good critical thinking skills, which I wouldn't expect most people to choose 1. But it's so loaded the way they asked it. There's so much baggage and morality and religion being tied up together. It's a problem.
Yeah. And it does seem simplistic also.
Yeah, it's like, it can only be one or the other.
I mean, they were trying to avoid biases by just asking them straight out, do you think that this guy's more likely to be an atheist or religious? So they were kind of to come through the back door to try to avoid those biases. But I think they just introduced a whole bunch of other biases that are hard to really even know. So,
and they primed the people too. Like they might not have ever even thought about that when they heard the story. And now they're saying, do you think he's likely an atheist? And they're like, oh yeah, now that you mention it.
Yeah.
He is probably an atheist.
What do you think of this component to it? For the participants, those who self-identified as being a non-believer, they were less biased than average, but still 52% of atheists selected that the person who did not believe in any gods was most likely that horrible person.
Yeah, I'm not surprised. I mean, that's just societal influence.
Yeah, totally.
That's a bias,
Yeah,
right?
it's just-
Yeah, that's a cultural
Absolutely.
bias.
Plus, 52% is not that impressive. I mean, that's just
No,
barely.
not that impressive either, but you might think on the surface it should be a lot lower than that, significantly lower than that because of their
Well, and also, did they discriminate between
Status.
atheism and somebody who is just not religious? Like, there's so many different ways people self-identify. There are many people who say, I'm not religious, or I don't believe in God, or I don't believe in a traditional God, or I'm against organized religion, who still don't call themselves atheists. Like, it's a complicated, like in these kinds of studies, words really matter.
They do matter, and there have been other studies that have taken place before this one which show the opposite being true.
Yeah, just too many confounds there. I don't think it's a clean experimental design.
But there are other surveys which indicate that people generally feel that atheists are immoral.
Yeah,
mean-
that's true. That's true.
I do by that.
Again, the cultural bias.
Yeah.
So
absolutely.
in a 2014 Pew survey, 53% of Americans say it's not necessary to believe in God to be moral, but 45% said that you did. So for those 45%, if you're an atheist, by definition, you're immoral.
Yeah.
Right.
And that's especially, and that's obviously Pew surveys are done here in the United States. I think the interesting component to the study that you talked about, Evan, is that it was international. I wish they had, it's like you're doing a survey. Ask them more than 2 damn questions.
Guess what percentage of Americans self-identify as atheist?
That's probably low.
Americans?
So not as non-religious, but actually use the label atheist.
Yeah,
15%.
I would think 15, but maybe it's
4
gone
to
up since
7.
then.
3.1.
Yeah. It's low.
3.1.
Oh,
Non-religious
that's
is
low.
very different than atheist.
Yeah.
Atheist
I know,
is a
but
very loaded term for a lot of
It is,
people.
and that's why that number is so low. It is actually higher than that, I from what I've heard.
Yeah,
Yeah.
non-religious, I think, is closer to 20% right now.
15.8. Nothing in
Really?
particular
Yeah,
is 15.8.
that's what I was thinking about.
but as of when?
So net unaffiliated is 22%.
There you go.
2014. Yeah.
2014. All right.
Yeah, but that none category is growing the fastest.
Absolutely.
Yeah. Well, in fact, atheists, by some measures, are more moral than believers.
Well, they definitely have. There have been studies that show that they are better at.
Moral reasoning.
I think yes, some of those exist, but that they have a better understanding of the Bible.
That's true. Yeah, that's true.
Yeah.
That's
They
actually
do?
true. Yeah.
And there was also a study that showed that they were more giving, more generous
Yeah. Right.
in certain contexts.
Interesting.
But I've seen studies go the other way too. I think a lot of it depends on the details, exactly what you're looking at.
Absolutely.
Because religious people are more connected with the community. And if the giving, generous, whatever marker you're measuring is connected to the community, then that gives an advantage to people who are religious.
And this is, of course, why these kind of psychological studies it's harder to tease this kind of stuff out because.
Yeah, there's so many variables.
Yeah, people aren't independent variables. You cannot make
Right.
a person an independent variable because they carry so many confounds with them. That's why they call them subject variables in psychology. Like, you just have to remember that there's baggage that comes along, and you have to try and think of all the other things that come along with being an atheist, like not having a congregation.
Right.
So what are we actually saying is the causative factor? It's tough.
Now, bacteria, they're a lot simpler, right, Kara, like anthrax?
Oh yeah, totally simple. Cool write-up, really good write-up by Ed Yong in The Atlantic, and it's based on an article that was like really recently published in Nature. It's actually a letter in Nature that was published, I want to say, I have the full text here, on August 3rd. Yeah, so just a few days ago. Persistent anthrax as a major driver of wildlife mortality in a tropical rainforest. This is fascinating. It's scary. It's a little disheartening. So anthrax specifically, the way that we think about anthrax, refers to a certain bacterial infection that's caused by Bacillus anthracis, or maybe it's Bacillus anthracis. I don't know. I'm going to say anthracis because that sounds like anthrax. And historically, Bacillus anthracis, the reason it makes animals mostly, sometimes people, but animals mostly, so incredibly sick is because it produces a lot of lethal toxins. And those toxins are actually what make the animals sick and potentially kills them. Bacillus anthracis Also historically seems to mostly affect ungulates, so hoofed animals. And in Africa specifically, which is where this study actually took place in the Ivory Coast, or in, my French is so bad, Côte d'Ivoire. I'm going to call it the Ivory Coast because my French is so bad. In Africa specifically, a lot of the anthrax infections that are seen by ecologists and biologists are in the savanna, and they actually have a periodicity with wet seasons. So for certain species, they might get sicker at the end of the wet season. For others, they might get sicker at the beginning of the wet season. But it's pretty easy to assess the percentages and the die-offs that are based on anthrax within a really nice cyclical pattern. But unfortunately, in the Thai forest of the Ivory Coast, these researchers noticed that some of their chimpanzees, which are incredibly threatened, these are endangered species, were getting sick and dying. And they were wondering what happened. And so they looked at these species and they found that they had a different kind of bacterial infection. It's actually not Bacillus anthracis, but it's a special bacterium called Bacillus cereus biovar anthracis. And they actually added that biovar anthracis. It's called BCBVA because it's a Bacillus cereus infection, which is usually inert, usually it doesn't make animals sick, that has taken on properties of Bacillus anthracis. So it actually has the same virulent plasmids in it that put off these horrible toxins, but it's a different species. And they noticed, okay, some of these chimps have this, so they did this really smart study. They'd been collecting bones since 1989 and actual fresh carcasses since 1996 and taking samples of them. So they had 75 different individual mammals' bones and then 204 fresh carcasses. And they were able to do some whole genome sequencing. They were able to do a lot of different tests to look at different markers and to see what these animals may have died from. And they found their results shocked them. And these were not just chimpanzees. These were creatures that had died in the Thai forest. They found that BCBVA DNA was in 81 carcasses, 40% of the animals that they had found dead in the forest. They found that 26 of the bones, the older bones they had tested, were infected, so that's 35%. And overall, they were able to observe a 38% local wildlife mortality associated with this one bacterium. And it wasn't just chimpanzees. They found it in some monkey species. They found it in duikers. They found it in porcupines. And they even, and this is where they're making some assumptions, but they think it's a good starting point for their research, they found it in some flies. Because the thing that was really confusing to them, typical anthrax, the spores are actually laid down in the soil. And so when you have these changes in the wet and dry seasons, the spores become aerated, and the ungulates who are grazers, they end up getting sick from the anthrax. They have no idea how, for example, this monkey species that they found had high levels of BCBVA, how the hell they would have gotten it. And so they're thinking maybe it was these carrion flies who were eating these dead bodies and then flying up to the treetops. Because actually you can't catch anthrax person to person or animal to animal. You have to eat it. You have to catch it by eating infected tissue or by breathing in the spores. As of whether or not the local people have died of anthrax, they say they have no confirmed cases, but there's also really no way to know. This is a really, really remote part of the world.
Yeah, but we do have to keep in mind that there's always these bugs, bacteria, viruses that are evolving in animals, and occasionally they're going to jump to humans. We never know when we're going to experience the next HIV, right? Imagine
it's true.
A while ago there was a world before HIV, and now we take it for granted. But you wonder, what's the next thing like that going to be?
And let's remember, too, HIV came from a similar region. It came from the Congo, of course, not from the Ivory Coast. But, these are places. And it's unfortunate that some of our closest animal relatives live in places where some of the deadliest diseases have natural reservoirs, because chimpanzees are critically endangered.
Yeah.
And it's really unfortunate. They actually estimate that if nothing were done about this and they can't get ahead of it, that all of the chimpanzees within the Thai forest could be wiped out within the next 150 years based on the rate of death that they're seeing with the epidemiological studies.
All right, let's move on. Jay, it's Who's That Noisy time.
But first, let's talk about QED. Now, if you remember last week, we had a contest, and the contest is still going on. And this is a contest that QED is putting on to win tickets to go to QED this year. So if you didn't know, QED is a absolutely fantastic science and skepticism conference that happens in, tell us all about it, Steve.
In Manchester.
That's right, in Manchester. That's in England. If you don't know where that is, please get a map and a clue. Here is the contest. There are 2 people on this podcast that have appeared at QED. And the answer is Steve and Kara. Now, if you know the answer to this, if you know the answer to the contest question, email QED at sgu@qedcon.org. You have to write the answer in the email with your name, and there's a few other stipulations in order for you to win tickets to this conference. First, you have to be able to go to the conference. Right, you have to be able to get yourself to the conference. You get free tickets into the conference, but nothing else is included. The conference is in Manchester for the weekend of the 14th and 15th of October of this year. And we are very likely to announce the winner on this show next week, right? So that is sgu@qedcon.org. And you have to answer the question, which 2 people on the SGU have appeared at QED?
That's a tough one, though.
Tough one.
That's right.
Yeah, I don't know if I'd get it right.
Yeah.
All right, so on to Who's That Noisy? So last week, you heard this sound. Any guesses, guys?
Goldfish clearing its throat.
That did kind of sound like a goldfish clearing its throat. I'm going to go with Bob on this one. GWB.
Okay, it's 2 people for goldfish.
I think
clearing
it's
throat.
a shrimp masturbating.
Oh, boy. Oh, boy.
I feel like those are in the same category of guesses.
No, this is a thermal vent, a hydrothermal vent.
Cool.
Wait, are you supposed to just tell us that?
Cool.
Yeah, because there were no
close.
winners this week, Kara.
Oh.
No winners.
okay.
We had, there were guesses, and the only one that I'm willing to read on the show was sent in by Jordan Hensley, and Jordan said that was underwater welding, which I thought was a really interesting guess, and it happened to be underwater, which was good.
Yeah.
The other guesses I got, there was just nothing there, not even a good heartbeat there.
Shrimp masturbating and goldfish clearing their throats are also underwater. I'm just saying.
What is a hydrothermal vent? It's a fissure in a planet's surface from which geothermal. I just
Yes,
dude, I love.
Yes, please.
I love
Only
that
ever
word.
say that
That's
again.
the best word I've made up this week.
That's so good.
It's a fissure in the planet's surface which is heated by underwater volcanic activity. And in these and these are commonly found in places that have tectonic plates and moving and spreading centers and things like that. So it's a super hot vent of water that's coming out of a place that's superheated by volcanic activity. That sound, that noisy, was sent in by a listener named Andrew Crochmal. Okay, so we have a new noisy this week, and this noisy was sent in by a listener named Nathan Grange.
Who saw you? She saw me. Whom did she see? She saw me. Did she see you or hear you? She saw me.
A robot.
What I would like for you to do is tell me exactly what we're hearing, and don't be vague. Yeah, a robot. So,
That's a very specific answer.
on the next episode of the SGU, you will find out the answer. And you should also be emailing me all the cool noises that you heard this week at WTN@theskepticsguide.org.
thank you, Jay. One email this week. This one comes from Rosalie Brown in Mayfield Heights, Ohio. And Rosalie writes, "Hi guys, love your show. Have to tell you you misspoke about Laetrile, and this mistake is important because a lot of people may quit eating almonds because of it. You said that Laetrile comes from the kernel of the almond, whereas Laetrile is distilled or extracted from apricot pits. Big difference. We'll be listening for the correction. Thanks and keep up the good work." Okay, so I found this whole topic interesting not because of almonds are so interesting per se, but because it demonstrates how much hidden complexity there is in every aspect of life. Just everything just is so much more complicated than you might at first think. So, okay, what's going on here? So actually what we said on the show was that amygdalin, which is the chemical that contains cyanide and is out of which Laetrile was created, was first isolated in almonds. That's why it's called amygdalin, because amygdala means almond. And Laetrile is mostly made from apricot pits, although it can also be made from bitter almonds or peach, plum, or apricot pits, any of those. But then it turns out that, we did say almonds, and there's a lot of complexity as to what that means, actually. Did you know that there's two kinds of almonds? Anyone?
You said bitter, right? There's bitter and sweet.
Yeah, there's sweet almonds and bitter almonds.
And we don't eat bitter almonds.
We don't. So in the United States, bitter almonds are actually they're illegal, they're banned. And in other countries too, like I know it's New Zealand. But in Europe, in some countries in Europe, you can get bitter almonds. So if you use the word almond, if you just say almond, you're talking about a sweet almond.
Sweet almond.
Yeah. Mm-hmm. And sweet almonds are basically cultivated from bitter almonds so that they don't have as much cyanide. The bitter almonds have about 45 times the cyanide content that sweet almonds do.
Whoa.
So sweet almonds are perfectly safe to eat. They contain only trace amounts of cyanide. You would literally need to eat thousands of them, in a sitting to worry about getting to toxic levels. And you can eat them raw without any worry about the cyanide. Bitter almonds contain a lot of cyanide. If you had 50, 60 of them, you could theoretically get enough to make you sick and maybe even a lethal dose.
Wow.
Yeah, so but you can roast bitter almonds, which deactivates the cyanide-containing chemicals, and then they can be safe to eat.
But do they taste good?
So from what I read, they're more bitter than the sweet almonds, but some people claim that they have a richer almond flavor. And of course, if you roast them to get rid of the poison, then you get that sort of rich almond flavor. But other people...
Richer poison.
So now you can also make an extract from bitter almonds to use in cooking, but you also then have to make sure you purify them and you remove the substance which contains the cyanide. Now, for added confusion, the term bitter almond extract can refer to bitter almonds per se, or you could substitute apricot pits or like peach or plum pits, and those can also be called bitter almonds, even though it's coming from apricot pits. So any of that type of substance you get from any of those sources is still, from a culinary point of view, considered bitter almond.
Gotcha.
All right. So there's another layer of complexity that I ran into so I had heard, and I've read dozens of sources on this, and they're all slightly wrong. You know what I mean? So a lot of sources will say that almonds are poisonous and you have to cook them in order to eat them, but that's only true of bitter almonds. Sweet almonds that's not the case. And I think that the confusion comes in because there is a big controversy over whether or not you can sell raw almonds in the United States. In California, which is the source of almost our entire almond industry.
Yeah, California is it.
They have a law that says that you have to pasteurize the almonds, which is mostly done through heating them. So if you heat them, and the purpose of that is not to inactivate the toxin, but to kill bacterial contamination. So that's where I think where people get confused. It's like, you have to roast the almonds before you can sell them, even if they're sold as quote unquote raw. They're not completely raw. They've been heated. And some people,
but they're not quote unquote roasted, right?
No.
I've seen packaging that says unroasted.
Yeah, so there's roasted, unroasted, and raw, and you could legally claim that pasteurized but heated but not roasted almonds are quote unquote raw, and that's where the controversy comes in. But again, to the thing that's interesting is the confusion that has created, because then some people think that they have to be heated to inactivate the cyanide, but it's actually just to kill bacteria. And they're confusing it with the need to roast bitter almonds. Okay, so then there's the raw controversy that there are some almond growers that want to be able to sell truly raw almonds that have not been pasteurized because they think they taste better.
Even though they'll kill you?
Yeah, so they say that you can exactly.
That's the way you want to go, I guess.
The law does have a loophole. If you are selling to the consumer in small amounts, you can sell them unpasteurized. And so some people will buy their almonds directly from the grower so they can get them quote unquote truly raw and not this fake raw that's been pasteurized. But that
sounds like one of those scary LA stupid health things that's going to kill you.
Yeah, I agree. I mean, and from what I've read, some objective like journalists making the comparison said they taste slightly different. They actually, some people prefer the heated almonds because they're crunchier. They're not as squishy. But maybe the flavor is slightly stronger in the unpasteurized almonds. So I'm not willing to risk bacterial infection for a slightly stronger taste.
Yeah. If you want softer, non-crunchy almonds, eat Marcona almonds. They're delicious.
Yeah. So there's all these different layers of complexity. The confusion of almonds with bitter almonds, with bitter almonds from apricot pits, with roasting for pasteurizing or heating for pasteurizing versus inactivating the cyanide. So a lot of sources didn't get it quite right. And I had to do a deep dive to really make sure I had all the facts straight. But none of this actually directly relates to our topic because we were talking about Laetrile. We weren't really talking about almonds. And I think all we really mentioned was that it was isolated from almonds.
I think the concern of the person who wrote in, or the couple of people who wrote in, was that they were afraid that us talking about it might deter people from eating almonds because they're afraid of the cyanide content.
Yeah, but but sweet almonds have negligible cyanide, so don't worry about it.
Yeah. Right. So making that point clear is important. It's like the same when people first hear that apples have
seeds
cyanide,
have cyanide,
right? In the apple
too,
seeds? Yeah. And then they're like, I shouldn't eat apples.
Sure.
I'm going to poison myself. It's like, no. And yes, bananas are radioactive, but you should still eat them.
Yeah, right.
They're good for you.
But again, it's funny because this is the same natural movement that then will obsess over trace amounts of other things, right? But we could ignore the trace amounts of cyanide in almonds because almonds are natural, or what I mean? So they're inconsistent in their reasoning where, I'm willing to say, trace amounts of anything that's well below toxic levels. Yeah, don't worry about it, whether it's cyanide in almonds or whatever.
Or botulism injected in your foreheads.
Formaldehyde in pears, yeah. All right, hey guys, let's go on with our interview. We are joined now by Dr. Jeffrey Hall. Jeff, welcome to the Skeptics Guide.
Hi, Steve. Glad to be here.
So Jeff is the director of the Lowell Observatory. So as you might guess, he is an astronomer. Your degree is actually in physics, right? But you're an astrophysicist, basically.
Yeah, undergrad degree in physics, graduate degree in astronomy, yeah.
Right, so you put those together.
Astronomy is just physics of out there, So.
Right. It's physics everywhere else but the Earth.
Astrophysics.
Right. And full disclosure, Jeff is a personal friend of mine. We're actually old college buddies. We were housemates at Johns Hopkins.
And they played D&D together.
That may have happened. But we're not going to chat too much about our old college hijinks. We're going to talk mainly about astronomy. So I understand, Jeff, that you are a solar stellar spectrograph expert. Your main focus is stellar astronomy?
You got it. Yep. And just like any field of science, astronomy is highly specialized. So, you can't possibly keep track of everything that's going on in the field at a full technical level. So, yeah, people specialize, and some in planetary, some in galactic. Mine has always been stellar.
And what's the main focus of your research?
Well, we are doing a very long-term program here, observing both the sun and stars similar to the sun, and so observing their spot cycles, their activity cycles. So not just the 11-year sunspot cycle, but analogous variations on stars like the sun. And the way I always put this when I'm talking in say, middle schools is imagine your teacher giving you a report to write on people, and you try to do it by observing just one person. You get a pretty narrow viewpoint. And ultimately, the goal is to understand how the sun has varied on timescales of centuries, even millennia. The sun is the fundamental driver of energy input to the Earth. It affects climate. Solar variations, or the lack thereof, are known to have significant climatic impacts in the past. And so this is kind of trying to put an astronomical perspective on the whole climate change issue, which is a very interesting place to be these days.
Yeah, I imagine.
So if you've looked at sun-like stars, you looked at Tau Ceti as well?
Actually, that is one of the ones on our list. Yep. And it's a very interesting target because it's very quiet. It doesn't appear to have much of a cycle. And the sun itself sort of seems to have shut down its cycle for a period of about 70 years, the so-called Maunder minimum back in the 1600s, which corresponds to a period of significant climatic impacts here on Earth. So it's stars like Tau Ceti that are actually of particular interest to us.
Yeah, the reason I brought that star up is that star was in the news recently. It's the closest sun-like star, I believe, 12 light years away, something like that. And they recently found 4 Earth-like planets around it, exoplanets.
Mm-hmm. Everywhere we look, we're finding planets, and the technology is finally getting to the point. You can find these little ones and not just these giant Jupiter-like things, with a 3-day orbit or something.
Yeah. So Jeff, I imagine you can't actually directly see sunspots on other stars, right?
Right.
So how do you study sunspots on other stars?
So that's the motivation for the spectrograph. You can image the sun directly. There's a very limited number of other stars where you can do really crude images if you have exactly the right kind of telescope and interferometer. But in general, no. Stars are point sources. But you take the spectrum and you disperse the light and you get all the spectral lines revealed in pretty good detail. And as it turns out, some of those lines are quite sensitive to the presence of activity. So spots,
that's
flares.
awesome.
Yeah, so you see basically the line strengths going up and down, and you graph that, and you can make it. The stellar spectrum is like a fingerprint. Everyone is unique. Every star is a little bit different, and if you know how to interpret it, you can actually deduce quite a bit about what's going on a big plasma ball 100 trillion miles away.
Plus, I'm sure you looked at the sun itself too, and looked at those variations to say, okay, if these spectral lines vary, we could actually see the sunspots, and you could make the correlations and say, all right, that's what's happening on our sun. Maybe it's happening on other stars as well. Probably is.
Yeah, precisely. Our instrument is capable of piping sunlight and starlight into the same spectrograph, which is a little bit of a trick because of the enormous brightness difference. But the idea is to do both of those measurements with the same instrument, and then you avoid some of the inter-instrument calibration difficulties that come if you have, different types of equipment.
Isn't our own sun's activity recently a little bit underactive for historically?
Yeah. Yeah, this is actually why we're finding this quite interesting these days, because the present solar cycle is quite weak. And just back around 2006, some papers started appearing in the literature suggesting that we might be getting into a period of weak cycles or even another one of these grand minima. And at the time, it was kind of poo-pooed a little bit, but then, we had this very long, deep solar minimum around 2007, 8, 9. It was just
I remember that.
Yeah, and it was thrilling observing, right? It's just a flat line for 3 years before it started to pick up. And the present cycle's been very weak, and the predicting future solar cycles has turned into a whole cottage industry, but there are predictions that the upcoming cycle number 25 might be extremely weak. And that could have, I don't know what the climate impacts of that would be, but they could be non-trivial.
Mm-hmm. And what is the basic effect that has on the climate?
There's 2 things going on. We know that as the solar activity rises and falls, the entire sun gets brighter and fainter, but not by much. It's 0.1%, a part in 1,000. But at solar max, the sun is putting out more energy than it does at minimum. So over that 11-year period, the amount of energy impinging on Earth is, it's fluctuating by a little bit. The other nuance is the spectral distribution of that variability, which is not much in the visible, but quite profound in the ultraviolet and the X-ray. And, those substantially changing fluxes of radiation impact Earth's atmosphere and potentially could impact, say, the atmospheric dynamics. And if you have something that, changes circulation patterns a bit and moves the jet stream a little bit for 30 or 40 years, you can imagine significant impacts down in the troposphere on that. Now, I'm not an atmospheric scientist, so I'm speaking a little out of my wheelhouse here, but there are a lot of smart people who are trying to do those models to understand the effect of changing atmospheric composition. And the guidance we're trying to provide is, on the long term, how much might the sun really have varied? 0.1%, 0.3%, 0.4%, and the stars provide a little bit of a lens to try and deduce that.
Yeah. Now, I know this isn't the focus of our interview, but I'm sure some of our listeners are thinking, well, bottom line it for me, can the changes in solar activity explain our recent warming, or is that not true? Yeah.
No.
Are you sure?
Yeah, it's pretty definitive.
Think about it if you want. Okay.
It's probably there. And in fact, everybody says global warming, you think of it as a modern problem, but really, Earth has been warming since the end of the Little Ice Age around 1715. And the bulk of that early warming probably was, it was natural because it was pre-industrial. There were periods of cooling in the 19th century associated with some large volcanic eruptions. But over the last 40 years, the rate of the temperature rise, we don't see any changes in the insulation that could contribute more than about 15 or 20% of that.
Yeah, so like 80% of it is man-made then, at least.
At least, yeah.
Okay, great. All right, well, Jeff, actually the primary trigger for the interview is the upcoming solar eclipse.
The eclipse, yes.
Yeah. So we've been talking about that a little bit on the show. Evan has been waiting for 30 years, Evan, to see this eclipse.
38, but who's counting?
38 years, and
it's
very exciting. But what we want to know from an actual expert is what science is going to come out of this eclipse. What can you do during that precious brief event that we can't do otherwise? So
this is eclipses for a long time have afforded a unique opportunity to observe the outer atmosphere of the sun. So I hesitate to call them layers because they're really not layers, but most of the light we see from the sun, this dazzling light in the sky every day, is coming from the solar photosphere where it becomes transparent to radiation and everything comes flooding out. But above that are these very rarefied regions, the chromosphere and the corona. And they're so rarefied and so faint that any time outside of an eclipse, they're completely washed out. Mm-hmm. But during totality, and only totality, suddenly they appear. So you see the chromosphere as this ring of pinkish light right around the sun's limb, and that's characteristic of emission from hydrogen. Mm-hmm. And then this whitish glow of the more extended corona. Most of that is actually scattered photospheric light, basically photons scattering off atoms and coming to or electrons in the corona and coming to your eye. And when you look at that, you will see that it's very striated. You'll see loop-shaped structures in the chromosphere, sort of tendrils and loops stretching up into the corona, and that's all caused by the sun's magnetic field. So what people will be doing during the eclipse, there will be a network of telescopes set up across the path of totality, and it basically gives you the opportunity to make, an hour plus kind of time-lapse movie of the dynamics of the corona. There are a number of things about the outer atmosphere of the sun that have long been puzzling.
Why is it so hot? Yeah, why is it so hot?
Yeah, and the basic idea is the heat arises because of the strong magnetic fields. And the ability of those magnetic fields to confine plasma far above the surface of the sun, they can transmit waves through the field lines that can deposit energy into the upper solar atmosphere. And then periodically, if you have magnetic field lines of opposite polarity that reconnect, that also releases energy, i.e. heat, into the surrounding plasma. And there's a real practical interest in understanding how all this works, because if those eruptive events are violent enough, you get flares and coronal mass ejections, which are what lead to aurorae. If they're strong enough, communications disruption and disruption of power grids, which happens every now and then. But particularly in the modern age, we have this increasing swarm of hardware up there that we are highly dependent upon. I think we'd all have to go into hibernation if our smartphones stopped working. So increasing human presence for extended periods in space. And so, understanding better how these events happen is a practical importance.
But it's not just that. I mean, it's in space. I mean, you get a Carrington level event with a CME. I mean, you could basically throw us back into the 1800s. I mean, knocking out our entire electronic infrastructure, or most of it. Worst case scenario.
Worst case, if you got exactly the wrong or the most devastating type of event at exactly the right time and pointed in the right direction.
Right.
Yeah, there could be severe impacts. Fortunately, that kind of thing sort of scales like asteroids. The extinction level event asteroids there are not many of them, and there's lots of the little ones like Chelyabinsk.
Yeah, but a few years ago we talked about it on the show that they were talking about within the in the next decade. How did it go? Like in
percent? The probability of a Carrington level CME event over the next 10 years, 50 years, 100 years, and it was pretty high. It was.
So what do you? Jeff,
that was scary.
What do you have to say about it?
I actually don't have that number on the top of my head. It is. In a period of very weak solar cycles, really violent events like that are a little less likely. However, you can see very powerful flares and CMEs even during a weak cycle. So, yeah, it could happen, and we're very dependent on everything that's up there.
Jeff, is there any science that you're aware of that's going to be done during this total solar eclipse that wasn't done in previous ones? Because on average, we get a total solar eclipse every 18 months or so, right? So this isn't the first time scientists are looking at... No,
certainly not. I mean, the corona was observed back into the 19th century, and that's when, people began to realize that the chromosphere existed because you could see all of this pink stuff. And with the invention of spectrographs, they began to find these weird spectral lines that just didn't correspond to anything that made sense. And
Pierre Janssen, helium.
Right, and finally they figured out, this had to be coming from species of ions that don't exist at normal temperatures, that this had to be really, really hot. And then that launched trying to understand what we call the whole coronal heating problem. The unique thing about this eclipse is, 70% of the Earth is water, and, eclipses don't really care where they happen. A lot of eclipses, say on average 2/3 of them are going to be mostly over ocean. So if you want to go see it, you have to take some cruise liner out into the South Pacific. Or, maybe they go over some completely remote area of land. This one happens to be plowing completely across a densely populated continent.
The heart of the USA, that's right.
The heart of the USA. So it is possible to, set up shop along and get a long unbroken path, give or take clouds, and try to get observations of the dynamics of the lower solar corona, which is a neat thing to be able to observe.
And what do you got, about 8 minutes of observing if you're stationary?
2.
2 minutes.
2.5 at most.
That's all we get? Oh, no.
Yeah, it's a short one, yeah.
This is a very short totality because the angular size of the moon is a little bit smaller than it is during some of the longer totalities. So we will be up in Oregon. We're hosting a big event for the public up there.
Yeah, I'll be there too.
I'm going to Oregon too.
I'm not.
We will be in Madras.
I am going to go to Salem.
Yeah, I'll be just south of Salem myself.
Hey, you guys are on the wrong side of the Cascades,
What? Okay, so what are we going to not benefit from if we're there?
Well, I'm a little further east, but
the problem there is, this is by no means guaranteed, right? You may have a beautiful day, but west of the Cascades, you get the Pacific moisture coming in. So, I looked at when we were considering where to go, you just call up a satellite image and you see this nice knife edge of overcast right along the spine of the Cascades. And to the east, it's completely clear. So we're going to be, call it 70, 80 miles east of you. If it's cloudy in Salem and your idea is, well, we'll just drive over to Madras, I think the shorter answer is no, you won't, because there's going to be 100,000 of your closest friends trying to do the same thing. Mm-hmm. So the basic guidance from the Oregon DOT is you're not going anywhere on the 21st.
You better be where you want to be.
Be where you want to be. And the other thing they really are concerned about is the fires. Particularly on the dry side of the Cascades, it's tinder dry over there, and you're going to have people camping out with presumably, cars with hot tailpipes and their sterno cans and everything. And yeah, wildfire is, it's our biggest threat here in Flagstaff, right? We don't get hurricanes or floods, really. We don't get tornadoes much to speak of, but we do get fire. And it's in this arid country, when it happens, it is devastating. And I know that's a real concern up there with all those folks.
Well, what if you did this? What if you flew a plane with a sunroof down the path of totality? What, like hours of totality? Is that even possible?
No. Nope. The Shadow moves a lot faster than any plane because it's going to cross the United States in like an hour and a half or something. So you don't.
So you need an SR-71 or something.
Yeah, right. So if you have access to a Blackbird, you take it right up there, and
Mach whatever.
But you certainly can fly along with it and extend the totality, and that's been done for sightseeing reasons, for scientific reasons. The dedicated eclipse chasers do it. In fact, there was a total eclipse. I don't know, a few years ago, but I read an anecdote that there was a flight. I think it was like an Alaska Airlines flight from Anchorage to Honolulu, and the pilot basically came on the intercom and said, "Okay, folks, we are going to leave 30 minutes late, and trust me," because by doing that, they got to fly right through the totality on the way to Hawaii. And
wow! There's
pictures of it online. People took.
I hope they were prepared with the proper eyewear, though. Right? It's like, oh, take a look. Oh wait, you can't look at it.
So what I'm telling everybody is during those 2 minutes, if you are in the period of totality, in the path of totality, be sure to look straight at it. It is completely safe, and the visceral experience of this eerie, bizarre, dark, cold environment, you want to experience that and not spend all the whole time looking through your iPhone desperately trying to get the same picture that 50 million other people are going to get.
Okay, so I have a pair of solar binoculars and a solar telescope. Should I actually be looking through the solar telescope right as it happens? Would that be cooler?
It could be cool if you take a quick peek and you want to get a good look at the chromosphere and the corona. Go for it. But be sure, you've only got 2 minutes. Be sure to spend most of that just sort of experiencing this really weird environment you're going to be in. And the other thing is, it'll take an hour and a quarter to go from first contact to totality. And during that whole time, you absolutely must use the properly filtered telescope or the glasses, because you will, even if the sun is 80% obscured, you'll blind yourself if you...
Well, I'm going to miss it, so I don't have to worry about all of it. I'm holding out for 2024. That's
2024. 2024.
So where is it going to be in 2024?
Oh, so that's gonna give more of it's a northeast track. It comes into the U.S. Right around the Big Bend area of Texas, and then it's going to slice up towards Buffalo, New York. So it goes, right across the central. So there's this place in southern Illinois that's on the X, and so they get
interesting.
Two total eclipses in 7 years, and that one I looked it up earlier today. I think the totality for that one is more like 4.5 minutes.
Oh, wow.
Nice.
But so I could go home to Texas to observe that one.
You could. In fact, I think it's going to nail Dallas, for example.
Yes, I'm from Dallas. Perfect. I can stay with my mom. I don't have to spend $1,200 on an Airbnb.
So, Jeff, for someone in your career, is this the Holy Grail? Is this like the coolest thing that could happen?
It's pretty darn cool. It gives you an idea of, I always like things that illustrate the dynamic universe, because, the sky from night to night seems so static. I know our visitors here at Lowell get the idea that this is just a constant. And it's neat to show them things like we have a solar telescope fitted out with a hydrogen alpha filter. And if somebody looks through it and then comes back 20 minutes, you can see, that flare has actually evolved. And here, you can see the moon moving, and the sun disappears and then it reappears, and it's this visible dynamic thing, and it creates this completely bizarre situation on the ground with all the nocturnal animals starting to do their thing because they think the sun is set.
Weird.
Silly animals.
Right, and it gets colder, noticeably colder, so things like air currents begin to flow. If conditions are right, clouds pop up. You have this clouds forming in the path of the eclipse, just pretty surreal. And so I think the best way I can put that this kind of, it's sort of something that speaks to all of humanity. We had 5 years ago an annular eclipse here in Arizona. So
Oh, cool.
moon was so far it couldn't quite cover the sun, so it leaves this ring. And the totality was just 30 miles north of here. So we collaborated with one of the parks, the Wupatki National Monument. I gave a talk out there in this community room of an ancient Anasazi ruin, the ancient peoples of the era.
Neat.
And I was giving that talk and practically got goosebumps because I figured I looked it up. It was like April 13th, 804. A total eclipse came right across that region, and here I am, 1,200 years later, pondering exactly the same thing that those ancients must have pondered. And when we got to totality, there were 1,500 people out there, and everybody just broke into applause. And it wasn't even total, so it wasn't that dark. But, it's like these are the things that I think make us realize that there actually are common threads and common purposes in humanity, which is a nice thing to sort of see when you look at the news any evening. Yep. Mm-hmm. So I'm looking forward to kind of sharing the experience with a bunch of folks that I know will really appreciate it.
So Jeff, before you go, I have to let our audience know that at one point you and I were in a band together. I think people might find that
what?
An interesting bit of trivia. Jeff and I were in a band
back together.
It had a few names, but I remember Jeff's suggestion was Ascension. Remember that, Jeff?
Not Declination.
Yeah.
But do you remember what we settled on?
Pandemonium.
That is correct.
What did you guys play?
I played keyboards. If I hadn't gone into astronomy, I probably would have pursued a career as a concert organist.
Neat.
Wow.
So it's still
very cool.
I'm the sub down at the Episcopal Church here in Flagstaff.
Very cool. And Steve, I didn't know that you played an instrument.
I played the drums.
Oh, very cool.
Yeah, it was a lot of fun.
Wow.
It was. We shredded it.
Don't ever say that again. I do remember seeing a picture of Steve dressing like the drummer from Men at Work, right? You used to. That was your model, right, Steve?
I guess so. I have no.
Actually, they stole it from you, Steve.
We're rapidly descending into stories that could quickly become quite embarrassing.
Yeah. So, Jeff, it was great having you on the show.
Great to be here. I've really enjoyed it.
We should have done it sooner, but we will bring you back to talk about light pollution at some point. Absolutely.
Outstanding. All right. Well, thanks a lot, and
thank you,
talk to you
Jeff.
soon then. All right. Thanks a lot.
Thanks,
Bye,
Jeff.
It's time for Science or Fiction.
Each week I come up with 3 science news items or facts, 2 real and 1 fake. And I challenge my panel of skeptics to tell me which one is the fake. You guys ready for this week?
Yes.
I suppose.
Grumble, grumble.
Okay. These should be interesting. All right. Item number 1. Paleontologists have discovered the new largest dinosaur known, a titanosaur that weighed 76 tons, almost as much as the space shuttle. Item number 2. Astronomers have discovered a new class of variable stars that oscillate over minutes rather than days. And item number 3, a new analysis concludes that a 1,500-year-old petroglyph found in Colorado depicts a nearby supernova. Evan, go first.
Ooh, these are cool. All right. So the first one, paleontologists discovered the new largest dinosaur known, Titanosaur, 76 tons. Almost as much as the space shuttle. Well, something in my head is telling me that this is old news. So I am probably wrong about that. I could have sworn this news was like 2 or 3 years old. But that must have been the previous largest dinosaur, maybe 75 tons. I don't know. So that's confusing me a little bit. The next one, astronomers have discovered the new class of variable stars that oscillate over minutes rather than days. I guess I'm not surprised. It's just cool. I'm not all that surprised that they've found it. We're finding all sorts of stuff. Exoplanets and rogue planets and all sorts of great stuff out there. So I think this is totally plausible that they would have found this oscillating over minutes rather than days. That is an extreme difference, but I think it does exist. So much, the universe is so expansive that almost everything exists out there, I'd say. Just a matter of finding it. The third one, a new analysis concludes that a 1,500-year-old petroglyph found in Colorado depicts a nearby supernova. Oh gosh, this is not unprecedented. I think in the year 1000 or something, a petroglyph was also discovered depicting a supernova, but this one's 1500 years old. I wonder if you're trying to trick me on conflating those two. I'll say the dinosaur one, Titanosaur weighing 76 tons. Just because, again, my brain's maybe playing a trick on me that this is old news, therefore something's wrong with this one, and I'll say that one's fiction.
Okay, Kara.
New largest dinosaur known, a titanosaur that weighed 76 tons, as much as the space shuttle, almost as much. Okay, the part that's confusing me about this one is that I'm pretty sure the space shuttle weighs way more than that. Is this like just the shuttle part of the space shuttle? I don't understand. It's not like the whole entire thing with the boosters and everything connected to it, right? Am I allowed to ask that?
Nope.
Shit. Okay. Astronomers have discovered a new class of variable stars that oscillate over minutes rather than days. A new analysis concludes that a 1,500-year-old petroglyph found in Colorado depicts a nearby supernova. Oh my God. These are all reasonable. I'm going to go with Evan on this. I think that part of number one is right. I do think that we found the biggest version of the Titanosaur so far, like the biggest actual individual one, but it's nowhere near as heavy as the space shuttle. I'm going to say that's the reason.
All right, Jay.
Yeah, this one about the dinosaur, I don't recall how much the space shuttle weighs, but there's lots of different weights that the space shuttle could weigh. Is it fully fueled? Does it have all the tanks on it? Is it just the shuttle itself? Yeah, if it's just the shuttle, you got to remember the shuttle, even though it's pretty big, it's not as big as you think, and I've seen the shuttle in person. It's not. I was surprised at how smaller just the shuttle by itself looked. It also has an empty bay inside, and it's made out of those tiles. So I don't know. I think this one is science. The second one here about astronomers discovering a new class of variable star oscillates over minutes rather than days. I haven't read anything or know anything about that, so I got to skip to the next one here. And I think that the petroglyph thing is science as well. They could have easily seen some type of supernova and then recorded it in the rock with the artwork there. Sure. So I think the oscillating in minutes is the fake.
And Bob.
All right. So number one, Titanosaur. Yeah, this seems fine to me. The thing is, though, with a big discovery is that there's lots of milestones during a discovery. There's the day you uncover the bones and you know you've got something good. Then they could study it. Then they could do a write up on it. And so all these milestones can kind of make it seem like an old story, is being rehashed. It's like, no, but, it's just one of the milestones in the life of this scientific item. So, yeah, that sounds about right. Titanosaur, the weight sounds right. The comparison to the space shuttle, which I'm interpreting as just the space shuttle, nothing else, that sounds right, too. Yeah, so I don't imagine that I would be off by, an order of magnitude on any of that. So that sounds good. The third one, the 15-year-old petroglyph, yeah, I guess that's sure, why not? The only thing that disturbs me a little bit is that, I'm not aware of any supernovas that have been discovered from only 1,500 years ago. Am I forgetting one? Maybe that timing is off, but yeah, that makes total sense. Makes a lot more sense than number two. These variable stars, like Cepheid variables, yeah, they vary over a longer period of time, like days, I guess. I'm not sure specifically, but minutes sounds way too small. I can't imagine a star oscillating over the entire star over in minutes. That would be crazy fast, too fast, I think, from what I know about this stuff. So I gotta think that one is the fiction.
Okay, so we got 2 for number 1 and 2 for number 2, so I guess we'll start with number 3 since you all agree on that one. A new analysis concludes that a 1,500-year-old petroglyph found in Colorado depicts a nearby supernova. You all think that one is science, and that one is the fiction.
Oh my God!
Whoa! Good job, Steve.
I should have done it. I was going to go with that. I didn't regret it.
So fine. We'll get there. So, Evan, there was this claim circulating a while back about a petroglyph depicting a supernova. It was a myth. That's not true.
Really?
Oh, is that the science that it was debunked?
No, but this is that just happens to be true, that there was a myth about a petroglyph supernova. That just was never true.
Wow.
The recent news item that I was basing this on was a recent paper published. This was by CU Boulder professor emeritus J. McKim Malville, who claims that a petroglyph is a depiction of a total solar eclipse.
Oh, neat.
I should have freaking known that.
But I didn't want to use it. I thought I almost used that as a science, but I'm like, I don't really buy it though. So I don't, I don't know how to say it.
Oh, interesting.
Without being too. So it's just suggestive. I mean, it's basically a circle with little loops around it. You know what I mean? So, and he's saying, the loops is like the corona, during totality. It's like, okay, but I mean, that's it.
Maybe,
that's all you got
not.
to go on. It's a circle with the curly things. But what the study that they did was they said, okay, well, if that was what the sun looked like during a total eclipse, that would mean that there was a lot of solar activity at the time. And they said this would have been correlated to a solar eclipse that happened in 1097. So they said, let's go back and find out from looking at carbon-14 isotopes what the sun activity was at that time. If there was a minimal activity at the time, then that would be less consistent with the picture that we're seeing. If it was a lot of activity, that would be consistent. And they found that there was high solar activity at that time. But yeah, that's a coin flip. That's a 50-50. The fact that there was a lot of solar activity, it doesn't, I don't think, support that much the conclusion that this circle with the little curly things was an actual depiction of the solar eclipse, rather than than a flower or whatever, than a million other things.
Could
that
have
are
been anything
with curl. Yeah, it's just way too thin. I think a line of evidence, which is why I didn't want to use it as a science. But it is interesting, and it's not impossible. It's just, who knows what the hell they were trying. I think the line of evidence is way too thin to draw that conclusion. So I made it into a fiction. Okay, let's go back to number 1. Paleontologists have discovered the new largest dinosaur known, a titanosaur that weighed 76 tons, almost as much as the space shuttle. This one, of course, is science. So the dinosaur was discovered in Argentina. The previous record holder was a titanosaur called Argentinosaurus. This one was found in the Patagonia region and is called Patagotitan maiorum. The Patagotitan for being found in Patagonia, and the maiorum is after the people on whose farm it was found. So
I totally tweeted about this earlier today. I'm so bummed.
Yeah.
I tweeted that it got its name.
Tweeted about it.
That's what you wanted to say, Kara?
No, I just I obviously have read all about this. I was having a hard time with that damn space shuttle part.
Yeah.
Wait, you tweeted about it. I was standing under its ribs a week ago. The thing is magnificent.
Yeah.
I love how they have the head poking out of the doorway because it's so damn big. It is magnificent.
It's the first dinosaur to get its own room at the American Museum of Natural History. And guys, there's this super cute viral campaign that the AMNH is doing right now where it's a motion graphic of the blue whale texting with the titanosaur or the Patagonia,
cute.
About how he finally got his name. He's like, he's like, I hear everything around the museum. It is like the cutest thing. I'll forward it to you.
Yeah, I want to see that.
So the space shuttle weighs 82.5 tons empty.
Empty!
Jay's interpretation is correct. We're talking about just the orbiter, empty. Is 82
just the orbiter, I'm thinking about that massive
tons.
Fuel tank.
Yeah, if you fill up that fuel tank, it's way, way more. Yeah, obviously.
All right.
Yeah, some reporting said as much, but then I checked and it's a little bit more, so I had to say almost as much because it wasn't quite. But it's interesting to think of a dinosaur weighing as much as that orbiter,
Yeah.
Oh, yeah, definitely.
Okay, let's go to number 2. Astronomers have discovered a new class of variable stars that oscillate over minutes rather than days. That one is science, to Bob's chagrin. Very interesting. So these are pulsating blue stars.
And they're big. They're big too, right? Isn't that blue stars big?
They're called, well, there's blue dwarfs, and then there's large blue stars.
Yeah, I guess so.
So these are called BLAPs.
What?
BLAP, BLAPs, for blue large amplitude pulsators. BLAP. You like that, Bob?
No, I don't like that name. For that.
He doesn't
like
it
Blaps?
at
It might grow on me.
Yeah.
I'm just still bummed that I lost. Meh.
Yeah. These are very, very rapidly oscillating stars. So most stars are stable. They have, like our sun, there's an equilibrium point between gravity pulling in and the pressure of all the heat and energy pushing out, and then that reaches an equilibrium point, and then the star is stable. Cepheid variables basically are oscillating around that stable point,
and they are incredibly valuable because they're standard candles,
yeah,
which tell us distances.
But they oscillate over tens of days typically.
Right.
There's also another type of variable star, Bob. You remember this one?
The Lorry stars.
Yeah, Lorry stars.
Yeah.
And they have even longer periods, but BLAPs can oscillate over minutes, 20 minutes, 30 minutes.
Whoa, man, that's
so
intense.
a lot shorter. Still
I'm
not
shocked.
clear exactly what's
shocked.
happening. Yeah. So the new study found that they're blue stars, that they're big, they're not dwarfs. So they've expanded, and they're very hot, of course, which is why they're blue. The temperature of a BLAP could be 5 times greater than that of our sun.
Wow.
What is going on in the interior to have the entire huge star, transitioning in such a short period of time? It must be one active star.
Yeah.
I wouldn't want to be near it.
Know.
I don't think I would want to be near that mother.
Right. So that's the next mystery to solve, is exactly what's causing it.
I thought I killed this one. God damn it.
You got blapped. Bob, you got blapped.
I know. I can't handle
We all
that
got
name.
blapped.
It sounds so ridiculous.
I called 2 out of 3. No, I didn't. I got the third one wrong. I called 1 out of 3.
That's the thing. When you're wrong, you actually get 2 wrong because you had to call a true one fiction and the fiction true.
Hell, we got bitch blapped.
Bitch blapped.
All right, Evan, give us a quote.
I suppose it is tempting, if the only tool you have is a hammer, to treat everything as if it were a nail. Oh yeah, that's a famous, famous, famous quote. Abraham Maslow from The Psychology of Science. Maslow's hierarchy of needs. You know where I first learned about that? Perry, of all people. He was talking about that as part of his lecture he was giving at Southern Connecticut State University back in 1998. And that was the first time I had actually ever heard that term. Went and looked it up. So I appreciate that, Perry. That was really, really cool.
Yeah.
That quote has filtered down into the medicine culture a lot. We use that to refer to like the blinders that a subspecialist can have. You know what I mean? Like if you're a surgeon, everything is a surgical problem to you.
Right.
Right. If you're a radiation technologist, then everything is treated with radiation, whatever. So, or if you're a chiropractor, right, everything is chiropractic. It's the same thing. So specialists, obviously we need specialists. I'm a specialist. You have to be a specialist because there's just too much knowledge. Everyone can't be a generalist, but it does give you these blinders, and it's basically a cautionary tale. It's like, don't let yourself think that the world doesn't exist outside of your specialty,
right.
Or don't do something just because it's in your specialty. You have to understand that there's this temptation to think that the tools that you have at hand will be useful for any problem, but they won't necessarily be.
Yeah, it's a common colloquialism we all say nowadays. I think everybody uses it at some point. If you're a hammer, everything looks like a nail.
Yeah, exactly. All right. Well, thank you all for joining me this week.
Thanks,
you got it, brother.
Thanks, Steve. Blap.
And until next week, this is your Skeptic's Guide to the Universe. The Skeptic's Guide to the Universe is produced by SGU Productions, dedicated to promoting science and critical thinking. For more information on this and other episodes, please visit our website at theskepticsguide.org, where you will find the show notes as well as links to our blogs, videos, online forum, and other content. You can send us feedback or questions to info@theskepticsguide.org. Also, please consider supporting the SGU by visiting the store page on our website, where you will find merchandise, premium content, and subscription information. Our listeners are what make SGU possible.